In this video, we will discuss about role of vinculin that can affect the linear relationship of force and FAK signaling. In the previous video, we have understood the role of tailin, and from that we have found out that tailin plays a role towards this FAK signaling and its linear relationship with the force. Today we will discuss whether this vinculin also has the similar effect or shows some different effect, and why we are checking, or the researchers have checked the effect of insulin, because insulin plays a role towards the interactions between actin and tailin, as from our one of our video uh, related to this paper also shows that actomycin plays a role towards this FAK signaling rather than FAK kinase. So they used a different construct of the vinculin. They use wild type vinculin, vinculin without tail, and the vinculin with the mutations in the head. And they also use a condition where uh, they introduce vinculin in the conditions where vinculins are not present within the system. So for the wild type, they can see that. So let's check out the results in the panel B, where we see that FA force, effect of FA force on this different kind of insulins. So for the wild type, they can see the FA force are significantly higher compared to the case where no insulin are present. When they uh, introduce insulin in these conditions where no null insulins are present, they can see a regain of some FA forces. And in the case where they mutated the head portions, they can see some forces, but in all the three cases the FA forces are lower than the wild type controls. And one of the reasons that researchers has find out that this mutated vinculins can interact with the actin, but they are not able to interact with the tails. Not able to interact with the tail. Yeah. And when they check the total FAKs, in this case they see some one of the surprising results is that compared to the wild type, in the case of null vinculins, they see increase in the total FAK intensity or focal adhesion kinases. And similarly, where they reintroduce the vinculins, they see a increase in the kinase activities, but the major increase they have seen in the case where no insulin are present. And but compared to the wild type, and when the insulin is again reintroduced in the null insulin case and the mutated insulins, they see a total focal adhesion kinases intensities similar to each other, but for the case where null insulins or no insulins are used, they see a highest total focal adhesion kinases. Similarly, they also check the phosphorylations or the activations of these focal adhesion kinases, and they can see there is no effect of any kind of insulins conditions on the phosphorylations of these focal adhesion kinases. Thereafter, they check the relationship of the force and total focal adhesion kinases, and relationship of force and phosphorylations of these focal adhesion kinases. For the wild type, as expected from the previous results also, they see a linear relationship, but for the null case and where the vinculin is again reintroduced, and in the case where mutated vinculins are used, they do not see a linear relationship. So all this indicates that the wild type insulin plays a role, has a role towards this has a role towards maintaining the linear relationship between FAK signalings and the force that is exerted on the cells through this focal adhesion kinases. So, and any changes or mutations in the insulins will affect those linear relationships, whereas they can still see focal adhesion kinases intensities and activations of focal adhesion kinases. So this is what the researchers has represented, that insulin's effect on the linear relationship of the force and FAK signalings. If you need to understand more about this experimental results in detail, you can go through the reference that has been provided in the description. That's all for this video. Thank you for your time.